So f of t equal to 5t square I plus tj minus t cube k, and then find the integration of 1 to 2 f bar d square f by dt square into dt. Now find the solution of f bar d square f by dt square into dt. So that is nothing to what is that? F bar df by dt, then integration is 1 to 2. So given f is 5t square I plus tj minus t cube a, then df by dt is, that is become 10ti plus j minus 3t square k. Now find f cross dou f by dou t. So this is I j k. So 5t square t minus t cube, and the derivation 5t square derivation is 10t and t derivation is 1 and t cube derivation is minus kt square. Now do the cross product. So that's we are doing the cross product, and we are getting this is that we know the cross product in the intermediate level also. So when you are doing the cross product, then we are getting this after the simplification. So we are getting minus 2t cube I. Now you should apply the limits, that is 1 to 2, that is minus 14i plus 75j minus 15k. Okay, so this is that. 7 point. Let's see the one more problem, and this is important for the short answers in the theory examination. Now the suppose f equal to minus 3x square I plus 5xyj, and evaluate f dot dr, where the c is the curve y equal to x square from 0 comma 0 to 1 comma 2 in the xy plane. Since the integration is performed in the xy plane, then z equal to 0. Then we take r bar equal to xi plus yj. Therefore, then dr equal to dxi plus dyj. So in xy plane, so in the xy plane, the z equal to 0, no? So that's why we are taking only dxi plus dyj. Now that f dot df, so that is become minus 3x square I plus 5xj, and dr equal to dxi plus dyj. Now do the dot product. So when you are doing the dot product, so we have to multiply these two. So that's why minus 3x square into dx, and this is the 2. That is 5xy dy. So there are the two methods are there. So first we go to the one method, that x equal to t and y equal to x square. So then the parameter equations of the curve is become x equal to t, y equal to x square. So here there is various from 0 comma 0 and 1 comma 2. Then that is t, the limits are become what is that? That is 0 to 1. Then that is f dot dr. So that is minus 3t square into dt. When place of x we have to substitute t, and in place of y we have to substitute 2t square. So that we are getting minus 3t square into dt. The total the function is changing into t. Okay. Now that's after the simplification, and we are getting minus 3t square plus 40 into t power of 4 minus t cube plus at power of 5. Now see the apply the limit 0 to 1. After that we are getting 1. So this is when we are changing into completely in the one variable t. Okay. Now let's see the second method. Substitute y equal to x square, then where x is varies from 0 to 1. So integral of f dot dr, so that is x equal to 0 to minus 3x square into dx plus 5x into 2x square into d of x square into dx. Now here we are completely variables in the x. Then we are substituting that y equal to 2x square. So that is dy dx now. So in the place of y we are writing what is that 2x square. So d of 2x square into dx. So completely that is become minus 2x square plus 40x power of 4. So after the integration, so we are getting that 7. So this is the one. Now the evaluate the integral x square y into dx plus x minus y into dy plus xy into dz, where the c is the arc of the parabola y equal to x square. And in the plane z equal to 2, and from the curve a equal to 0 comma 0 comma 2, and b is 1 comma 1 comma 2. So since the curve is y equal to x square and z equal to 2, then dy by dx will become 2x. So when you are doing the differentiation of uh, y equal to x square with respect to x, dy by dx equal to 2x. And z equal to 2, z equal to 2 means that is dz equal to 0. So it's follow that on the see the integral of the last term is given that integrated to 0. So this is why, because the dz is 0 now. So when you are substituting the dz is 0, this part is going to the 0. Now see the integration of x square. Y is what is that x square? So x square into x square plus dx plus x minus what is the z? Z equal to so x minus 2. What is the dy? So dy equal to 2x into dx. The completely we are changing into the x variable. That we are changing into x variable. So that is become 0 to 1 x power of 4 into dx plus 2x square minus 4x into dx. So now do the integration, that is x power of 4 plus 2x square minus 4x into dx. So that we are getting x power of 5 by 5 plus 2 into x cube by 3 minus 4 into x square by 2. Then integration up to the integration 0 to 1, and we are getting the numerical value minus 17 by 50. So this is a one of the form. Now let's see one more problem. So evaluate integral of the line integral of the function x square by dx plus y square z into dy plus z square into x minus dz, where the c is the curve from origin point 0, 0 to a 1 comma 1 comma 1 and along the line 0 a and along the curve x equal to t and y equal to t square and z equal to t cube. So the given equation line OA equal to x equal to y equal to z. So the OA equal to x square y into dx plus y square minus z into dy plus z square minus x into dz. So here they given x square minus x plus x square minus x and x cube x square minus x into dx. Why? Because they given that x equal to y equal to z and along the line x equal to y equal to z. So that's we are getting dx equal to dy equal to z, and in the same way in place of y we have to substitute x and in place of z also we have to substitute x. So finally we are getting equal to 3 into 0 to 1 x square minus x into dx. Then we are getting that after simplification minus 1. Along the curve x equal to t and y equal to t square and z equal to t cube. Then dx equal to dt and dy equal to 2 dt dt and dz equal to 3 t square into dt. Then integral of x square y into dx plus y square minus z into dy plus z square minus x into dz. So x equal to t square and y equal to t square into dt and y square in y equal to t square, no? So y square is become t power of 4 and z equal to t cube and dy equal to 2 dt and z square into t power of 4 minus t into dz equal to 3t square into dt. So just after the simplification, so we are getting 2t power of 5 minus 2t power of 4 plus 3t power of 8 minus 3t cube that equal to 2 into t power of 6 by 6 minus t power of 5 by 5 plus 3 into t power of 9 by 9 minus t power of 4 by 4. So now apply the limit 0 to 1. So after the simplification and we are getting minus 29 by 60. Next here the B part. Along the curve x equal to t, x equal to t, y equal to t square and z equal to q. Then dx equal to dt and dy equal to 2t dt and dz equal to 3t square dt. So that is x square minus y equal to dx, y square minus z into dy, the z square minus x into dz. So here x equal to t, t square minus t square into dt and y equal to t square, no, that is t power of 4. See, this is after the simplification and we are getting minus 29 by 6. So pi equal to 2x y z square and f equal to 2xi minus zj plus x square k, and c is a curve x equal to t square and y equal to t and z equal to tq. So from t equal to 0 to 1, then evaluate the integral of f dot pi dot dr and f dot dr. So evaluation of pi dr. So along the curve pi equal to 2xyz square and x equal to t square and y equal to t and z equal to tq whole cube. That is become 4t power of 9. And that is r bar equal to xi plus yj plus zk. That we are getting t square I plus 2tj plus t cube k. And dr equal to 2ti plus 2j plus 3t square into dt. So integral of pi into dr is 0 to 1 4t power of 9 and 2ti plus 2j plus 3t square into dt. So thus we are getting 8t power of 10 into dt and j 8t power of 9 into dt and k 12t power of 11 into dt. So after the integration and we are getting 8 by 11 into y plus 4 by 5 into j plus k. Now along the curve C, one more f bar equal to xyi minus zk plus x square k. So that will become x equal to t square and y equal to 2t and z equal to t cube. Now f dot dr. F dot dr I j k 2t cube minus t cube t power of 4 and 2t plus 2 3t square into dt. So you have to do the cross product. So when you are doing the cross product and we are getting minus 3t 5 minus 2t power of 4i minus 4t power of 5 into j plus 4t square plus 2t power of k into dt. Now see the one more problem. Suppose a force field is given by F bar equal to So next to the path independence. So force field F is a conservative field F when it is the nabla cross F equal to 0. That is F is irrational. So what is the meaning of F is irrational means when that nabla cross F equal to 0 then F is called what is that irrational. Okay, let's see how it is happening there. So F is a conservative field, then F bar equal to lambda phi. So then curl F equals. So curl of grade phi equal to that is become 0. So conversely we are taking that lambda graph F equal to 0. So ijk that is dou by dou x dou by dou by dou by dou z F1 F2 F3 equal to 0. So when we are doing the cross multiplication and we are getting rho f3 by rho y equal to rho f2 by rho z, rho f1 by rho z equal to rho f3 by rho x minus rho f2 by rho x equal to rho f1 by rho y. So now we prove that so f3 is a conservative field, then f bar equal to lambda. So this work done is moving the particular x1, y1, z1 to xyz in the force field f bar. That is f1 equal to x comma y comma z into dx, f2 equal to x comma y into z into dx, then f3 into f3 x1 y1 into dx. So where C is the path joining this between x1 y1 z1 and x y z. So let us do particular straight line segment x1 y1 z1 to x y1 z1, and here also x y z1 to x comma y comma z. So this is also just we are doing the dou f by dou y part and dou f by dou z is x3. Here this is important. Show that the vector field F is given by y plus sin z into y plus xj x constant into k find the scalar potential. So curl is equal to I j k and dou by dou x dou by dou y dou by dou z is y plus sin z x and x constant. So that is equal to I into 0. So when you are doing this dou by dou f into x y cos z minus dou by dou z minus j into cos z minus cos z and plus k into 1. So now let f equal to lambda phi, so I into dou f by dou x plus j into dou f by dou y k into dou pi by dou x equal to y plus sin z. That is plus the phi equal to xy plus x sin z plus we are getting to the constant f of y. That's dou f by dou y equal to x, then phi equal to xy plus y of xz, and dou phi by dou z equal to x into cos z, and that equal to z equal to x into cos x into sin z. Z cos z integration is sin z, then x into sin z plus z into xy. So the above is so phi equal to x sin z plus h of xy. So therefore the above equation is represented f of y z equal to 0 and g of x z equal to x into sin z and h of xy equal to xy. So therefore the function phi equal to xy plus sin z plus